Hello. Now, if you watched the previous video, hey, thank you. I hope you're not too mad at me, and I didn't file too many complaints in the comments there. But in the previous video, I talked through the feed-forward algorithm. I attempted to map it and graph it. I attempted to get all the indices right, to explain why we use matrix math for it, all that sort of stuff. Now, at some point we got to get to the interesting part, which is actually to use the neural network for something. It's taking me a while to get there. I will get there. But I absolutely need to confess, if you thought that was bad, I actually, Wilderness Dan over here, tried in a live stream previously to go through all this and got all the index values and everything wrong. It was so bad I couldn't even get it together to turn it into an actual tutorial video that would make it into the playlist. But it does exist if you're interested. I got a haircut, seemed to fix a lot of things. I look like a much more professional person. You can go back and watch that those previous attempts. So, and I've actually done, so this is my second try. I'm just being honest here. All right, so what is it that I want to do, in this particular video? We can close all this stuff. What I want to do is, I have a matrix class that I've developed. I have a neural network class that I've developed. What I want to do, I want to be able to write code like the following. I want to be able to go into my P5.js sketch or any JavaScript program and say something like, let NN equal a new neural network. Maybe I want to solve XOR. So I want to have two inputs. I just want to have two hidden nodes and one output. So I want to make a neural network object and I want to give it an architecture. Then I want to do something like I'm going to make an input, like I want to send in true, false, 1, 0. I want to be able to say let output equal neural network feed forward that input. And then I want to say console log output. So this is the code. This is what I want to be able to do. I want to be able to use the neural network on a kind of higher level. And once I can do that, then I can have inputs that are all different kinds of things, whether I'm doing some data science or some kind of learn to play Flappy Bird or whatever it is that I'm doing. Okay, so let's do this. What I have so far here is just, I have that feed forward function. It takes an input and returns that guess. Now, there's no code there. I need to fill in the code, all that matrix math. I need to take everything that I have here and I need to put that all into here. So how do I do that? All right, well, my neural network needs some more stuff. For example, all that it has right now is the number of input nodes, which is I just sent in 2, the number of hidden nodes I sent in 2, and the number of output nodes I sent in 1. Well, what I need is I need to keep track of those weights, right? I need to have weights. And what do I need to have weights between? I need to have the weights between input and hidden, and the weights between hidden and output. So those we've established are matrices. Weights between input and hidden is a new matrix. And now it has a certain number of rows and columns. It has a certain number of columns based on the number of inputs, and rows based on the number of hidden nodes. So we're going to say it has this dot hidden nodes is its number of rows, and this dot input nodes is its number of columns. So that's one weight matrix. And another weight matrix is between hidden and output, and that's going to have the number of rows, which is the number of output nodes, and the number of columns is the number of hidden nodes. So I've created these weight matrices. Now, we have an interesting question. When we create a neural network, how do we pick the weights? Again, the whole point of this is we need to have some interesting, wonderful, exciting, complicated, weird algorithm for tuning the weights, for finding the optimal weights for whatever type of application we're trying to build. But to start, we just want to give it random weights. And this is a whole field of research dedicated to figuring out good ways to seed a neural network with good kind of beginning weights so that you can get the optimal weights more easily, blah, blah, blah. But for us right now, I just want to give it random weights. So I can actually just say we've already built a randomize function into the matrix library. So I can say randomize. So this will randomize the weights. And actually, though, if you recall, I was reminded by this in the chat that my randomized function for some of my demonstrations, I was actually picking a number between 0 and 10. And it would make much more sense to get a random number between maybe -1 and 1 to start at the weight. So I could take math.random, which is 0 to 1, multiply by 2, subtract 1, and I've got a random value between -1 and 1. OK, so we're doing well. What else do I need? I should probably keep track of the bias, the hidden bias and the output bias. Again, as we saw when I was sort of talking about it, I could put that into the matrices, but I'm going to keep track of that separately. It's a little easier for me. So I'm going to say this.bias hidden equals a new matrix that has, how many biases do I have? I have, based on the number of hidden nodes, right. Those are the rows, and then one column. Is it? Yeah, because it's a one column vector. And the bias for the output is based on how many output nodes. So for I need a bias value for every node in every layer. So I need 2 bias values for each hidden node and 1 bias value for the single output node. But again, my neural network library allows me to create neural networks with any number of hidden nodes, any number of inputs, any number of outputs. It just has these 2 layers and the inputs, but so at some point it might be worth expanding it, so I got multiple hidden layers, that sort of thing, but this is going to work fine for now. OK, so what else do I need now? Aha! So there's something we're missing. So for example, let's just, what am I feeding in here? Feed forward input. This is just an array. But technically, in order for me to be able to do the first stop, right? The first thing that I want to do is I want to say this dot hidden. Oh, I'm sorry. I'm going to make this let hidden. This will be the output, right? I want to compute the output of the hidden nodes. That's going to be a one-dimensional, one-column matrix. That is going to be the matrix product between the input and this, and the weights, and the weight matrix between, and actually I have to say the weights first, sorry. The weights, remember the order in matrix multiplication really matters. The weights input hidden with that input. Then I'm going to say hidden dot add this dot bias. So I do the matrix product of the inputs and the weights, then I add in the bias, and then I'm going to do activation function. I won't do that just yet. But even this is no good so far. This is no good so far because this input, what does this matrix multiply function expect? Matrix multiply in my library expects 2 matrix objects. And this, the way I've written my sketch, is I just made the inputs an array, which is an incredibly convenient thing to do. I don't want to make my end users have to figure out, they just want to be able to send the inputs in a simple array. So one thing that I should do here, I could test, I could check if it's already an instance of a matrix, I could skip it. But what I want to do is I want to say, I'm going to call this input array. I want to say inputs equals matrix from array input array. And the reason why I'm writing this out is because I've thought of this already. I need to be able to make a matrix object from that array. So I want to be able to have a matrix object so that my matrix multiply function will work. And I could create a different constructor that takes an array, but I think what would make sense is for me to add right up here in the beginning, right, a static function that's called from array. It takes an array. And what I want to do here is I want to say let m equal a new matrix that has a number of rows based on the array's length and 1 column. Right? I want to create a matrix that looks like this. It has a number of rows based on the array's length and 1 column. And then all I need to do is say for let I equal 0, I is less than array dot length I plus plus, and I'm going to say data, m dot data index I index 0 equals array index I, and then return n. So this is just, again, I'm sure lots of you could probably think of some type of array functionality that I could use really easily, but this is creating that matrix and then putting the input into it. So just to be sure about this, let me say m.print. Okay, let me just make sure this works. So I have some errors here. Oh, that actually nicely printed something out for me that I didn't realize it would. So what I want to do is I want to say let array equal 1, 0, -5. And then I want to say matrix dot from array. And we should see, there we go. We've got a single column matrix, 1, 0, -5. So that function is working the way that I hoped it would. So I can take out this debugging and I can keep this in here. And now if I go back to this code, I can say, okay, we get an input array. We turn that into an input matrix. And then, this needs an S here, we multiply, we do the matrix product of the inputs with the weights. We add in the bias. Only one more step left to go. We need to do the activation function. So we need the sigmoid function. Well, it so happens that there isn't a magical sigmoid function that exists in JavaScript. However, there is in the math library a function called exp, JavaScript math. Let's find this documentation page. This exp, Euler's number, or also known as Napier's constant, does for us e to the x. So I can write my own sigmoid function. So I can just, and at some point I probably will allow the neural network library to use different activation functions. But right now I'm just globally going to write a function called sigmoid. It's going to take one input x, and it is going to return 1 divided by 1 plus math.exp -x. Somebody fact check for me, but I believe that is the sigmoid function. And so the wonderful thing now is once I've received the inputs, once I've done the matrix product of the weights and the inputs, once I've added in the bias, I can generate the outputs with the activation function just by saying hidden.map sigmoid. If you recall, I wrote into my matrix library a function called map, which just allows me to apply any arbitrary function to every element of that matrix. So there we go. Now we're done. So this is all the code for generating the hidden outputs. And this is the activation function. Now, where are we in the diagram? We've got the inputs. We did the matrix product. We added in the biases. We passed through the activation function. Now those outputs are coming in here. So what do we need to do now? Take those hidden outputs and do the matrix product with these weights. So we're going to do exactly that same thing. We're going to say let output equal matrix.multiply this dot weights. Now I need the weights between the hidden and the output, HO. I need the hidden outputs, which is I'm just calling hidden. Then I need to add in those output biases. Did I call it bias O? Yes. I need to, oh, and by the way, I just realized I never gave these any initial values, so it would make sense for me to also randomize these. So I'm going to randomize those biases. So now I've got the weights times the matrix product of the weights and the hidden outputs. I'm added in the bias, and then output.map sigmoid, and guess what? Return output. That's all I want. That's done. That's the last piece. I want to send in the inputs. In my actual code, I want to be able to send in the inputs and then read out the output. But here's the thing. I sent in the inputs as a simple array and then internally converted that into a matrix so I could do all the math properly. Now, before I get the outputs back, I don't actually want to send out a matrix. It's going to be simpler if I just send out those outputs as an array. So much like I wrote that from array function, I am going to create a function called toArray. And that doesn't need to be static because I'm going to take any given matrix object and return an array. Now, there are some, I could probably transpose it and do some fancy way or use the slice function. Again, I'm going to do this just in a way that I know will work. We can always refactor this later. In the end, I'm going to refactor all this using somebody else's matrix library anyway. So let me think about how I would do this. First, I want to make an array. I'll make it empty. And then really all I want to do is I want to loop through every element of the array, every element of the matrix. And what I want to do is I just want to say array.push every element of the matrix and say return array. So this would actually take any two-dimensional matrix and flatten it to a one-dimensional array. The question is, though, one thing we should ask ourselves here, is it appropriate to have the columns as the inner loop? So if I think about it, if I wanted to take, I mean, obviously it doesn't matter if it's this matrix, because I just want to take all these and put it into an array. But if it's this, if I want to take like this array and flatten it, do I want to go do, or do I want to go do? I think I want to go this way. I got distracted by my own singing of that's the iteration song. Is just All right, sorry. I'll get back to this. I apologize. I think I want to iterate through the columns on the inner loop, which it looks like that's what I'm doing. So I'm going to keep it this way, except for okay. So I'm going to keep it this way, and I'm going to say here now in the neural network, I can say return output.toArray. Okay, everyone. This is it. This is the whole feed-forward algorithm. This is receiving the inputs, generating the hidden outputs. Generating the output, and then sending it back to the caller. All right, so this is the whole algorithm. This is like layer 1 and layer 2, the hidden layer, the output layer. Okay, what do we do now? Let's try running the code. I mean, it's absurd, but because this does nothing, but let's just run this. Let's just see, can I create a neural network, give it some arbitrary input, and get some output? Can I get it with no mistakes? It seems very unlikely that I'm going to have no mistakes. And this is the reason why I shouldn't use my drum roll effect, but I'm going to do it anyway. Okay, here we go. Let's run this code. Oh my God! It worked the first time. Now here's the thing. It worked is the strange thing to say, because really I didn't get any errors. And probably the only reason I didn't get any errors because this is actually my second try of building this out. And you might be wondering like, oh, okay, so I just watched like 2.5 hours of like 8 videos in a row about matrices and neural networks. And you just went for 0.593107. The thing is, we got to start testing this. We've got to come up with this area. We're getting close. What I want to do, probably the first thing I'll do, it's not that interesting, but at least allow us to test whether this code works, is can I train it to learn an AND operation, an OR operation, or XOR, exclusive OR, which is one that I've talked about that can't be solved with a single perceptron. So can I feed it in 1, 0 and train it to get the number 1 out? Can I feed it in 0, 1, train it to get the number 1 out? But if I give it 0, 0, 1, 1, I get the number 0 out. So I need to attempt that. But I am missing a lot of functionality from this neural network class. I have this feed-forward algorithm function. Now what I need is to write a function called train. And what I'm going to do with the train function is I'm going to give it some inputs, and then I'm going to give it a known answer. So the idea here is like with feed-forward, I'm really just saying, take these inputs and give me an output. With training, I'm going to say, take these inputs that I have a known labeled answer to and do something to yourself based on that. And that's what I'll start getting to in the next video. I have to talk about back propagation and gradient descent. I have talked about this in previous videos. We'll kind of return to that. Then I need to finish implementing this function. And then I'll do a coding challenge where I try to solve XOR and do like a simple digit recognition or something with this particular neural network library. Okay, thanks for watching. I'm going through this. I'm trying it out. I'm seeing if I can make this neural network stuff happen. I'm doing if I'm being honest, it's a B-. I think it's a B-. But all things will come eventually. So thanks for watching, and as always, I don't know, subscribe, like, That helps, supposedly. And because then YouTube's neural network, I'm just copying 3 Blue 1 Brown's joke at this point. You should watch 3 Blue 1 Brown's videos. They're really good. I learned so much just from like watching those. And so I'll be back in the next video at some point. Thank you.